Geometric proportions, the set.
Welcome to Mark's Math Methods.
A question could read, these triangles are similar, find the missing length. Or maybe it'll read it this way, the sides of this pair of triangles are proportional, find the missing length. Proportional means two ratios are equal, or another way to say it is one fraction equal to another fraction. Similar means that the values of corresponding angles are equal, while the corresponding side lengths are proportional. The key to any proportion question is relationships. You need to check the solving proportions presentation before continuing if you don't remember how to solve a proportion. Example 1. These triangles are similar, find the missing length. So let me walk you through this example question. So we have two triangles. One triangle has a vertical component that's 3 feet and the bottom that's 7 feet. The other triangle has a vertical part that's 2 feet and the bottom part that we don't know, x. That's the missing length we're trying to find. So the question you have to ask yourself is, where is the x? It's right there. What part of the triangle is it? Well, it's the bottom part. What is the corresponding part in the other triangle? Well, it's the bottom part of the other triangle. So we're going to take the x and the 7, and we're going to need to write a fraction. It doesn't matter which you put as the numerator or the denominator. So you could write 7 over x, or you could write x over 7. I'm going to put the 7 on top. So I'm going to use 7 over x. Now we need another fraction to complete the proportion. We will need two numbers. Since we used the two bottom numbers for the first fraction, we can either use the two numbers in the vertical part of the triangle, the 3 feet and the 2 feet, or these two, the numbers that represent the diagonals. Oops, there's no numbers here. So I guess we're having to use the 3 and the 2. Where does the 3 and the 2 go in this new fraction? The 3 came from the same triangle as the 7. Therefore, it must go in the same part of the fraction. Since the 7 was in the top, the 3 goes in the top. The 2 came from the same triangle as the x. Therefore, it must go in the same part of the fraction. So the 2 goes in the bottom of this new fraction. Now, here's how the relationships work. The first fraction is the bottoms of the triangles. The second fraction is the verticals of the triangles. So the parts of the fractions are related, the parts of the triangles are related in the fractions. The numerator is the left triangle, and the denominator is the right triangle. This is how I chose to set this one up. It would be slightly different if I had chose to put the x on top versus the 7. Woohoo, the hardest part is done. Now solve it as you would any proportion. So it's all about the relationship. These two rectangles are proportional. Find the missing length. Right answer as a simplified fraction. So we've got two shapes, two rectangles. The x is what part of the rectangle? Well, it's the vertical part on the left rectangle, the height. And the height on the other rectangle is 2 centimeters. So my first fraction is x over 2. We could have done 2 over x, but I've written it as x over 2. And now the other fraction, (9) over 7. So my first fraction is the heights of the rectangles, and my second fraction is the bases or bottoms of the rectangles. First fraction is the heights, second fraction is the lengths. The numerators happen to be the left rectangle, and the denominators are from the right rectangle. So everything is related vertically and horizontally. Let's try a geometric word problem. If the shadow of a 13-foot tree is 5 feet long, how long is the shadow cast by a 6-foot tall person? All right, if we had shapes, it would be easier. Well, anytime a word problem talks about physical shapes, always draw a picture. So this talks about trees and shadows and a person and the shadow, or if it talked about rectangles or triangles or circles, you'd always want to draw the shape. It makes the translation easier. So here's my tree, which I've labeled as 13 feet, because it's a 13-foot tree. And its shadow, I'll draw the sun here just for perspective, and the shadow is 5 feet long. And now my person, which I've labeled as 6 feet tall. And now their shadow, which I don't know, so I put an X. It says how long is the shadow, so that's my unknown. If we overlay 2 triangles, voila. And now if I set it up, 5 over x equals 13 over 6. Notice that the shadows are my first fraction. The heights are my second fraction. The numerators relate to the tree, and the denominator relates to the person. So everything is related horizontally and vertically. And so our setup would be 5 over x equals 13 over 6.
I hope the presentation was helpful. Thumbs up, subscribe, comment. And if you have any problem types you'd like me to demonstrate, there's my address.